Hi everybody, we're working on 7.2 Solve and Write Addition Equations. It begins on page 525. The first example says miniature golf. On the second hole of miniature golf, it took Annie 3 putts to sink the golf ball. Her score is now 5. She represents the situation with cups and counters. So like I would use sticks and dots and she's using cups and counters. This is all the same as the inquiry lab. And so the first thing says it wants us to fill in the boxes above to using the phrases below. That her score is the first hole is unknown, her score is now 5, she scored 3 in the second hole. So go ahead and draw arrows from each of these bullets to the one that you think it matches with. Pause the video now. Alright, so it looks like her first hole is unknown. Well, our unknown is always our variable, which is what our cup stands in for. And then it says that her score is now 5. We know that is going to be our our other side, our answer. And then she scored 3 in the second hole, and that's going to be what she started with the first. So we're putting the first 2 holes together because now her goal is, or her score is 5, and so we know that the second hole she had gotten a 3, and the first hole we don't know. That's the question mark. That's the variable, and then we know that in the end she's going to have 5 points. So write an equation, an addition equation shown in the figure. So pause the video and I want you to write an addition equation that's based on what you see there. And this is very similar again to what we did in the inquiry lab. So hopefully you have x plus 3, because our cup is our x and our 3 counters are 3 ones, equals 5. Now it wants us to explain how would we solve this. So think about that for a moment. How are we going to solve this equation? X plus 3 equals 5. There's a couple different ways that you've already learned. You've learned mental math. Of course you know what plus 3 equals 5. There's also using the counters where we would cross out the 3 over here, and then we would cross out the 3 over here, and we would see what we have left. And that's what's balanced out. We now have our cup left and 2 dots left. That means that they're balanced and equal, and so that x would equal 2. Number 4 says, what was Annie's score in the first hole? Hopefully you know that her score was 2, because 2 plus 3 will make 5 points altogether. So what we're going to talk about here is solving an equation by subtracting. In lesson 1 you mentally solved equations because it was kind of common sense, like what plus 3 makes 5. But we're going to have some harder numbers like fractions and decimals that don't make our mental math quite as easy, and we definitely need to know the strategy used to solve those questions. So inverse operations is what we're going to be talking about in this chapter. Inverse means to undo. What's the opposite? So when we think of inverse, we're thinking of undoing. We're thinking of what's the opposite. So in an addition equation, the opposite of addition is subtraction. When we get into 7.3, we'll have subtraction and addition, then we'll have multiplication and division, and then we'll have division and multiplication. Okay, so we know that these are how we undo each other, right? We undo adding by taking away. We undo multiplying by dividing. So example number 1 says 8 equals x plus 3. We're going to solve that. We have 2 different methods. We've had the method where we've used the models and the balancing if you want to, but we also are going to be talking more about using the t-chart. And I like using the t-chart. Well, actually, this is the grown-up way of doing it, and I insist that you use the t-chart because it helps keep everything organized. So let's first start talking about using models. So the way I would use model is having like my little balancing thing here, and I have my 8 dots over here, and then I have my 3 dots and my stick over here, and I know that I'm going to take away 3 of my dots, so that I can get the stick by itself. And so when I do that, I now have 1, 2, 3, 4, 5 on this side of my scale, and the other side of my scale I just have my cup left. And so I know that my cup is the same as 3 counters, so in this case my cup equals 5. Did I say 3 counters? I meant 5 counters. The other method is to write out the equation. So I've got x plus 3 equals 8, or 8 equals x plus 3. I'm going to put my line through my equal sign. My line always goes through my equal sign. I give myself some space to write, space it down, and now I'm going to use my inverse operation. So I know that my goal is to get x by itself. That means I need to get rid of plus 3. So what is the opposite of plus 3? Minus 3. So that's my inverse operation. Now, the reason we use the inverse operation is because if I take plus 3 and I do minus 3, I just got rid of my 3's, right? Because plus 3 minus 3 makes 0, and that's nothing. And so I get the x by itself when I do that. So what I do to one side of the equal sign, I need to do the other side of the equal sign. What I do one side, I do the other. So now I'm going to do 8 minus 3 is 5. 5 equals x. And of course, substitute and solve, we want to check our work as well. And so we're just going to take this 5, plug it into the x, and this is kind of just easy, fast math. 5 plus 3 makes 8. Check. Okay? It's worth it to check your work when it's that simple. So we're going to have you go ahead and use the T-chart this time for A, B, and C. So I know that we practiced using the cups and dots and counters and all that crap yesterday, but now I want you to work on using the T-chart, and that's going to be kind of helpful because in C we have decimals. So please pause the video, practice this on your own. Don't just keep watching and wait for my answer. I really want you to practice. Pause the video now. All right, so we just want to put our line through the equal sign. I see that I need to get C by itself by getting rid of a plus 2. So to get rid of plus 2, I'm going to do minus 2. What I do to one side of the equal sign, I do the other. That's why I put the line through the equal sign so I can see that I do this on each side. See that? So now I'm going to do 5 minus 2 because plus 2 and minus 2 make 0. And so all I have over here is C. 5 minus 2 is 3. I can quickly check my work by doing my 3 plus 2 equals 5 check mark. And so I know that my answer is good. So now that for B, I put my line again straight through the equal sign, give myself some space to write. I need to get the x by itself. That means I'm going to get rid of the plus 5. To get rid of plus 5, I'm going to do minus 5. Inverse operation. I'm going to undo adding by subtracting. Plus 5 minus 5 makes 0, so that's gone. So I'm left with just x. And then over here I've got 6 minus 5, which is 1. Now to check my work, I just substitute in for the x, 1. So 1 plus 5 equals 6. Yes, it does. So x equals 1 is correct. Here we go again. We get our line through the equal sign. I want to get the y by itself. That means I need to get rid of my positive 3.5. And I know that you guys get confused sometimes with things like this. If I want to get rid of a positive 3.5, that's the same as subtracting 3.5 because you know that 3.5 minus 3.5 makes 0. So I am going to subtract my positive 3.5 minus 3.5. I'm left with a positive y. And then over here I need to do my 12.75 minus 3.5. Make sure you line up those decimals. So it's going to look really nice and neat like this. 3.5, add in a 0 there, and then subtract. Drop down your decimal. And your final answer should be 9.25. Now to check your work, again, you're going to do that 3.5 plus 9.25. Line up those decimals. Check your work. 12.75, so I know that this is my correct answer. So I kind of just wait to circle it until I've checked my work to make sure it's correct. And that helps if you make any errors that you'll catch yourself and go, oh, I forgot it was supposed to be, I was going to line up my decimals, blah, blah, blah. So subtraction property of equality, it says in words, if you subtract the same number from each side of the equation, the two sides remain equal. So we've done that already, talking about our balancing, that if I have, let's say 3 dots over here, and then, okay, I can't get that to work, hold on. Oops. I'm going to get, here we go, 1, 2, 3 over here, 1, 2, 3 over here. If I take away 1 here and 1 here on both sides of the equation, I still have a good, nice, balanced scale. If I take away one more from one side, and I take away one more from the other side, I still have a balanced scale. And so think of your equation as a balancing scale. So it says that an example would be that if you have 5 equals 5 and you take away 3 from both sides, you get 2 equals 2 and we're still good. In algebra, that means that if we have x plus 2 equals 3, we can subtract 2 from both sides. And when I say both sides, I always mean through the equal sign. One side of the equal sign, the other side of the equal sign. I'm going to have a balance of x is equal to 1. And if I plug that back in, 1 plus 2 is 3, that would be balanced, right? It's kind of like taking away that those counters and leaving the cup on one side and whatever counter is left over on the other. But we're not going to use the counters anymore. Now we're just going to be using our addition skills and multiplication and division and subtraction. All right, so when you solve an equation by subtracting the same number from each side of the equation, you are using the subtraction property of equality. So example number 2 says Ruben and Tariq have 245.5 downloaded minutes of music. If Ruben has 132 minutes, how many belong to Tariq? So write and solve an equation to figure this out. So they used a bar diagram here. I know that for some of you you find that a little confusing, but they're just saying that whatever, it's 135 for Ruben plus Tariq's minutes altogether will be 245.5 minutes. Now, hopefully, mental math wise, you knew you're going to subtract, but if you need to write this, because it says to write and solve, to write an addition equation, instead of writing it as, 245.5 minus 132, which is how you would solve it, we need to make this into an addition equation saying that 132 plus whatever Tariq has is going to equal 245.5 minutes. So that's where they came up with this beautiful addition equation. Now we're going to do our t-chart, and we're going to get the t by itself. That means we need to get rid of a positive 132. To get rid of positive 132, we do minus 132 because that makes 0, right? 132 minus 132 makes 0. What I do to one side of the equal sign, I do to the other. So now we're going to subtract 132 from both sides. All right, so that means that Tariq has 113.5 minutes. And so we know Ruben has 132, Tariq has 113.5. Total, they have 245.5 downloads. All right, so now we're going to say, let's change this up a little bit. Let's say that Ruben had 147.5 minutes of the 245.5 that were downloaded. So now write another addition equation and solve that one to figure out that if Ruben had 147.5, now how much does Tariq have? So go ahead and write that equation, pause the video now, and we'll come back and look at that together. So hopefully you see right away that this is identical to what we did before. We know that we take 147.5 minutes plus whatever Tariq had, and it's going to equal a total of 245.5 minutes. Sorry, I'm trying to make that look right. So to be able to solve this, this is our first answer, okay? If you didn't have that, you're not going to get points. Then we're going to do our t-chart to be able to solve for the other part. Now, I want to get the t by itself, so that means I need to get rid of a positive 147.5. I do that by subtracting 147.5, but what I do to one side of the equation, I do to the other. So we're going to subtract over here. So now we have t by itself. We subtract, our decimal is 0. We borrow from here. Of course, our decimals are lined up nicely, right? We subtract, that's 8. Then we have to borrow again. We subtract, and that's 9. And so this time, Tariq has 98 minutes of music downloads. All right, hopefully you got that. All right, so you should always check your solution. You can always go back and say, okay, well, does 98 make sense? Let's plug it in. And does 147.5 plus 98 end up being 245? So let's figure it out. 15, carry that. Oh, sorry, I got a little excited. That's 14, carry that. And then that's 2. So 245.5. And that's what we needed, so we can circle our answer and say yes, 98 minutes is what Tariq had. Number 3 example, the male gorilla weighs 379 pounds on average. This is 181 pounds more than the weight of the average female gorilla. Write and solve. Again, we're writing the equation and solving it. 2 parts I want to see on your paper to figure out what the weight of the average female gorilla is. So we've got the man is 379 pounds, and this is 181 pounds more than the female. So we've got whatever the female is plus 181 pounds, and that's how much a male weighs, which is 379. So, and again, I put x plus 181. It can be 181 plus w, or whatever, okay? So this was the first part that they want. Now we solve it by subtracting out 181 from both sides. We get w equals, and when we do 379 minus 181, 198 is the answer. To check our work to make sure it's correct, I would just plug in the 198 answer that we got, add it to 181, and it better come up to 379, and it does. So that's correct. So my answer is W equals 198. All right, guys, that is the end of our section here. Just remember, we're using those T-charts. I want you to show your work really nice. Have a great day, and I'll see you in school.